All right, everyone. Very good morning, good afternoon. All right, so we'll continue the session. And yesterday we discussed about the EIGRP, lot of concepts. Before we move, anyone have any questions about the case study sessions? Any doubt? Any clarifications? Okay, so we'll continue the session, and I believe we left with the two topics. That is, one is the stub router in the EIGRP, because we discussed about that RD, FD, feasible conditions, and we need to discuss about the stuck inactive feature in EIGRP. And also we discuss about the stub router feature. We discuss about the load balancing, equal and equal load balancing. Also, one of the additional topic we discuss is summarizations. It's not part of this EIGRP, but we discuss about that. And we discuss the metric as well. IPv6 we discuss separately for the all topics. We have a different lab. So IPv6 we do different discussion in another session. So let's discuss about what is the stub router. Okay. In EIGRP, what is the stub router and how we can make the any router as a stub router. So in a stub router, if you talk about the stub router, just think about the router is located in very remote locations. Means you have any branch sitting in a very remote location, and further we not have any connectivity. So that's why stub router come in a picture in the AIGRP. And what basically they do that, let's suppose you have any special type of the locations where you don't have any kind of the other connectivity. Means you have very small branch routers which have the limited connections, and you don't have to send query about something about the your another network. So that's why means behind you don't have any other network information, so then you don't have to send any query when something break down in the network from your LAN perspective or your connectivity perspective. That's why you have to make that router as a stub router, so nobody is going to be expect you are going to send any kind of the means any network information to me. So that's why in EIGRP, we have the stub router connectivity features, means stub router feature, which have the limited connectivity. Branch router officially typically connected only the one distribution router and don't need to entire EIGRP router database. Means basically you don't have to perform the query for any kind of the route reachability, any kind of the updates and all. So for that, you need a stub router. And there is one more feature. There is a stuck inactive. So I'll discuss separately what is a stuck inactive. But by making the stub router of the EIGRP router, what is going to be happen? You are going to save unnecessary query flooding. So for that, you are going to save your CPU, memory, and bandwidth of the router. So you don't have to configuring a stub router, tell neighbor do not send me unnecessary queries. That simple meaning means you, once making the stub, behind me I don't have anything except my only connected network. Any network behind me I don't know. That's why it's known as a stub router. So if you just go in the Google also and search it, what is a stub router in EIGRP, you can just find in the book as well. So you can find that stub router often simply refer as a stub. Is special configurations used to primary and hub and spoke network. Means spoke is basically a branch where don't have any further connectivity. It's still the upstream hub router that has a limited connection and should not be used a transit part for data. Simple means you want to go any other location. I don't have any network, so you don't expect any kind of the updates from my side, and don't send me the keep query for any network lose connectivity. Means any network lose connectivity, don't send me the query to get the informations. So when hub and a spoke network experience a route loss, the hub router typically send the query packet to all neighbor to find alternative path. That is a EIGRP nature. So without a stub, you are going to get the query. All the spoke is going to get the query, and definitely they are going to process that query packet. So bandwidth utilization is going to happen, CPU utilization is going to be happen. But you going to make the stub that I'm the stub, so they are not going to send any kind of the query. And also they are going to avoid the stuck inactive feature. So what is the stuck inactive feature? I will discuss about that. So simply if I want to, let's suppose this is my one of the router and I want to make as a stub router. So how I can make this stub router? So to make the stub router, you simply go and define some kind of the configurations in the EIGRP configuration, and then after it is going to be become a stub router. So let me do that, how it is going to be do that. So let's suppose I want to make it as a stub router, this R3. So if you go here and show run section EIGRP. So we are running that that is a named mode. Even I'm running the classic mode. The both feature going to be utilized. So even the named mode, just go in the uh, address family. Let me. There is a feature. Can call. Let me do first here. Then I'll go in the named mode also. In EIGRP, go section EIGRP. Simply go here and use the command EIGRP stub. Okay. So this is the command you have to use. If you want to make this router as a stub router in the classic mode, I'm just going to check for the EIGRP modes, name node syntax as well. So classic mode, let's suppose this is my one of the router, which is the branch router. Take an example. So I want to make it a stub router, but this need to advertise their connected route or any other route which is learning from the LAN. So when you make this stub route, you also have to use the what you want to advertise. So you connected, do advertise the connected route. What is the connected route? That is your directly connected LAN interface. You want to use for any kind of the loopback interface. You want to use any other physical interface. Means whatever interface you have, tunnel interface, you can advertise by the connected. You want to leak the any route. We discussed the leak map, right? Yesterday. Leak map is basically you have to create the prefix list and you have to just advertise the specific prefix to be advertised in the your redistribution. Means you are going to advertise in the EIGRP. The leak map is going to be used there, and this leak map is basically going to allow your communications, and based on that they're going to be reach only specific prefix. If you are going to use the receive only, so only you're going to receive the routes. Redistribute means you want to redistribute any route. So in redistribute also you're going to find options further. You want to redistribute connected, static, summary. So you're going to do that also. You want to make the static. So do advertise the static route only. Do advertise the summary route only. So if you're doing any kind of the stuff, so generally we have the connected, so we can use the connected. So my connected route is going to be advertised, and you can see they just reform the neighbors because I just use this connected route advertisement. So all connected route is going to be advertised. So for me, what is a connected route? This is my connected route. Let me see that. Show IP interface brief. Yeah, this is my connected route 1 by 3. So if I go and check in the VIOS 5, show IP route. See, so this route start coming just 25 seconds ago. See, 25 seconds ago. Earlier it was not coming. So I make this router as a stub. So if anyone is going to be, let's suppose this router lose the any network connectivity. Let's suppose they lose the connectivity for the any subnets from the any AIGRP routing tables. So they will not ask this router to perform the any kind of the update. No, they will not send the query to this router. They know this is the stub router and they will not going to be ask anything to do that, query performance. So that is the stub. So configuring the stub router, tell neighbor not send us an unnecessary query to me because I don't have any other network. So you can just use this command, just check that what is happening to me. And when you're going to advertise, you just use the any summary connected you want to advertise, you can use the summary address as well. If you want to do a summary, and if you check this command, let me check this command in this particular neighbor. I'll go in the R6. Let me check it. Show IP EIGRP neighbor. So I want to check for the 16 daughter. We check this one. So you see here, see, so this is showing as a stub advertisement. So this never know that. You can see how to check my peer is a stub or not. So you're going to get a special flag here. This for this neighbor you're not getting any flag, but this one you're getting flag. This neighbor is this peer is advertising stub connected. So they all know this all neighbor. If you check for this one also, this will going to know that my peer is basically a stub router. So they will not going to perform any query in case of any kind of the reachability requirement. So you can run the command show IP EIGRP neighbor details. So you're going to find this also. You can see suppressing query. Clear is written that it's suppressing query. See, suppressing query. They are not going to send any query to neighbor. But if you check the on the this one R5 show IP EIGRP EIGRP neighbor details. In this, you are not going to find any kind of the stub because there is no stub. These all neighbor are not the stub. But for this point of view, these are not a stub and these are this is the stub router. So this is going to be always suppress the query. Okay. So this is a classic mode, how we can do that. Now let's talk about the named mode, how we can configure in the named mode. So let me go in the EIGRP and named mode. I need to go. Let me router EIGRP address family EIGRP stub. Okay, so you can just use the same EIGRP stub connected, and if you just place it, it is going to be same feature. So any connected route. So we don't have anything, but if any connected route is going to be there, you're going to be get that. So in name node also you can configure, but you just have to go in the address family and you have to configure. This is the EIGRP stub connected. Anything you want to send that. Clear guys, what is the stub? Any doubt? Anyone have? Okay. So that is a stub. And we have one more topic, EIGRP stuck in inactive. So what is a stuck in inactive? So stuck in inactive is the somehow related with the stub only. So what is going to happen right now in the latest iOS? If we talk about the modern iOS, especially from the 15.x onward, you will often not going to see that this log, I mean this stuck inactive is not going to be available. Even you try to exit the same state, means if you try to do the stuck inactive, it is not going to be available. This was the issue in the older logs, means before 15.x version, whatever the logs we have, under those logs, we have this kind of the problem stuck in inactive. But now in latest iOS, you are not going to find this kind of the problem. So let's theoretically understand because we cannot replicate this issue. If you check in the our version of the iOS show version, probably it's a latest version. See 15.4. So we cannot replicate this stuck inactive, and everything you're using in the right now in the productions, they all are the latest iOS version. So what is the stuck inactive? So in case of the EIGRP is going to lose the any routes. Similar, let's suppose any we make the stub router, right? And if you're not making the stub router and any EIGRP route is going to be lost. So what is going to happen? Your query flood is going to be start. Means every router starts sending the query. It's neighbor, hey, you know this particular route, you know this particular route, and they will wait for the that particular who is going to tell me that particular route information. If anyone is going to tell that route informations, based on that they're going to find the alternate path and they're going to be build the again connection with that alternate path. So you can see when EIGRP routers loses the routes, it's enter in the active state. Active means it's going to start sending the means passive is basically good state, active is a bad state. Okay, we saw now we see in the our table, we see in the EIGRP routes active and passive state. So if you go here and check show IP EIGRP topology, uh, let me say show IP EIGRP topology table. See, so P means passive route. Passive route is a good route. Active route is basically it's going to search, means this route will lost, right? So everything you see P. So passive is a good state, active is a bad state. So don't be confused. So it is going to stay in active state and send query neighbor asking alternate path. Hey, you know any alternate path? If all neighbor responds and respond, the routes reroute in the passive state. Means if you have the information about that neighbor, means that particular route from any neighbor, you are going to be turn out as a passive state. Passive state means you have the path to go to destination. However, if any neighbor fail to response within the active timer by default 180 seconds, so it will wait till 180 seconds. So if no one is going to respond or any neighbor is not going to respond till 180 seconds, this routes become stuck inactive. So it will form as a SIA route. Means it will try to get the information, but it's not getting information till 180 seconds. So basically it's going stuck inactive. So simple meaning, if I have one subnet 10.10.10.0 and I lose the connectivity, take an example from this route I'm learning from this router, and I lose the connectivity from this router point of view from the all neighbor. So what is going to happen? It will retry to send the query packet to all neighbor. Hey, do you know this particular route? Do you know this route? If anyone know from the alternate path, they will reply. Then it's good. It will become passive. But if this router is not going to reply, this router is not going to reply, this it does not have information. So in earlier older iOS, it was going to wait for 180 seconds. And if it is not going to get any reply, it will declare that particular neighbor is in a stuck inactive for particular routes. That's why you can see here, when there is no response from the neighbor to fail to connect within the timer, the route become a stuck inactive for that particular neighbor. So primary path become unavailable. So that is route failure. Query process, right? SIE condition, neighbor relationship terminated with no reply, right? And this is a kind of a topology you can see. If this is the topology we having, this route will lose that. And it send the flood to the all router. See, this network connected behind the LAN, okay? But we lose that connectivity. Now we are expecting my these routers are going to be give me reply about this subnet, but they don't have any knowledge. So they will flood the query, right? They will flood the query for the every routers, every neighbors, and based on the flood query, they are going to get the reply, but they will not get any reply because they don't have any kind of the knowledge about this particular route. So in that case, they are declaring as a that particular neighbors or that particular route from that neighbor is going to be stuck and inactive. But this is not available. As I mentioned that if you're using this iOS, this feature you're not going to find anywhere nowadays in the EIGRP. Okay, guys. So this is the stuck connected feature and this is the stub router feature. I hope you understand. So we discuss in detail. We added few more topic in this. That is a filter list. How we can apply means leak map. We apply that distribute list. How we can use a distribute list also. So we use a filtering, right, by using the route map, by using the access list. We using the distribute list also to just simulate some kind of the testing. We'll try to do a lot of things. We'll try to do redistribution also later on. Means we'll build the topology where EIGRP is going to redistribute it in the OSPF. So we'll do the separately discussion for that section, how the redistribution is going to happen and how route is going to exchange. But right now I'm just focusing on the pure EIGRP based configurations. Any questions? Any doubt till here? Anyone have? Okay, so if no doubt, no question, let me stop it and move to the OSPF sections. Okay, so let me bring the lab. Let me stop this lab totally. Okay, so let me turn on this lab. This is stopped. Let me start this all node. Let me give me 1 second, guys. Okay, let me find the ebook as well. Full ebook for the NRC. Labels NRC PDF. Okay, so I found the book. All right, let me open it here. Okay, so as we discussed in the very beginning of the session, we have the dynamic routing protocols, we have the static routing protocols, and EIGRP is one of the dynamic routing protocols, but that is a fall under the hybrid routing protocol, which maintain the property of the link state and also distance vector, and that's why it's become the hybrid routing protocol. But when I talk about the OSPF guys, OSPF is purely our hybrid, means it's the complete link state protocol. It's not the hybrid protocol. Means it's complete maintain the link state for the end to end. Means if you have any kind of the router and have any route from the any different locations and they want to communicate to you or your any kind of the neighbor, or might be you want to do the end-to-end communication. So they use the OSPF. If they are using the OSPF, they have the entire visibility like the Google map. So by sitting in the any location, if you want to go any other locations, you can easily understand what all paths are available, and by using those paths you can just go and reach to one source to another destinations. That is how OSPF is going to work, and this OSPF is known as the open shortest path first. It's a protocol, and that is the link state routing protocol, and this is non-proprietary of any kind of the vendors. Means it's open standard protocol and it can be used for the any kind of the devices. Means any vendor devices you can use in the Cisco router, you can use the Juniper router, you can use in the any kind of the HP router, Nokia router, any vendor router. If you want to use, you can use this protocol. This support VLSM, you might be learning the CCNA, variable length subnet mask, right? And it can also support the classless routing, summarization, authentication, external route tagging. Like it can support the IPv4 and it support the IPv6, right? Everything. So we'll discuss both of things. So initially we're going to focus about the IPv4, but later we'll focus on the IPv6 as well. But if we talk about the OSPF fundamental, as a link state protocol, how basically it's going to work. So there is a one point is very important. EIGRP earlier was the Cisco proprietary, but now still it's become a open standard. Any vendor can use this EIGRP. There's no problem. But still, most of the vendor like Cisco, Huawei, Juniper, they are not using the EIGRP. Cisco is using, but Juniper, Huawei, and HP, other vendors are not using this. EIGRP, but OSPF is like popular and everyone is using that. So everyone is going to be use OSPF. So OSPF is very important because it's a widely used routing protocols. It's a link state protocol. Why it's link state protocol? We discuss about they maintain the database. You can see they maintain the database that is known as the LSDB, link state database. For every route information, they're going to keep in their database and then maintain entire path topology informations, means which all path is available to go from source to destination like a GPS. So if you go in GPS, you're sitting in the one location, you try to search any other location, you going to get that all path informations. Like if I go for the airport, right? Go for direction. See, so we have the all path, alternate path, primary path, secondary path, tertiary path. Everything is going to be there, and based on that, you're going to be reached from one source to another destinations. All right. So this is how you're going to be. Your GPS is going to look like. So what happened in OSPF, being a link state protocol, it will not do any kind of the, I mean, OSPF router, link state means OSPF router do not send periodic update, means anything is going to be changed in the topology. They will not send the periodic update, only send whenever change will occur, means if you have the full topology converged, so they are not going to be do keep updates after some time. No, it's not like that. Means I have this route, I have this. No, once they send all database, and they everyone are going to maintain the database. It's very important. There's no periodic change, means update is going to happen. But if you're making any change in the your any route, any network, then topology change is going to be happen. Any new addition of route is going to happen. Then they will going to update to the neighbor. So incremental update is going to happen instead of the periodic update. So periodic update is means after some time you have to update about your routes, your tables and everything. But OSPF doesn't going to do that. It will do only in case of the you have any kind of the changes in network, right? This also is part of the IGP, means Interior Gateway Protocol, and this not required any kind of the AS number, but required the area, right? This OSPF used the one of the algorithm. That algorithm is known as the SPF algorithm. SPF. That is basically SPF is basically going to be used that Discastra algorithm. Probably you're going to find here shortest pass first. This is a shortest pass first, but this is going to leverage the Discastra algorithm. You can see here. Yeah. They always router run the Discastra sorted pass first algorithm for construct a loop fluid topology. That is the shortest path. Means they're going to find the best path to build the source destination network reachability, but they're going to use the Discastra algorithm. You probably find this Discastra algorithm in the internet blueprint. You can learn about it. This is the like. Let me just show you. It's going to be one of the blueprint. We cannot copy. Uh, so open shortest pass uses Kasar, also known as the shortest path algorithm, to calculate most efficient path through the network. Simple means which is the best path you have to calculate. So this Discastra is basically one of the I think who discovered this particular protocol. That's why it's known as Discastra algorithm. But they're going to use that what all the database we have, what is my cost associated with that database from the primary path, secondary path, and based on that they're going to build the shortest path tree, and they're going to get that your best path to reach the destinations. So this is basically algorithm of the Discastra. So if you want to learn that how was we implement the Discastra, you can just learn some blueprint, or that is the known as the white papers. So you're going to find that a lot of history about that. So you can see this is scientist. The algorithm was created by the published by the Dr. Adsger W. Disgastra. So it's a brilliant Dutch computer scientist and the software engineer. In 1955, he published the three-page article title and note on true problem is connection with the graphs, right? So he is the man who developed this discussor. That's why this process is going to leverage that discussor algorithm. So you don't go to have to history. You just have to understand how this discussor is going to work, and this discussor is going to work in terms of the just build the your shortest path first algorithm. Based on that, you're going to find the best path to reach the any source to any destinations. Okay. Now each routers see itself as the root or top of the SPF tree, or that is known as the STP, and also SPT contain all the work destination within the SPF domain. What is that? So shortest pass first, right? Shortest pass first is basically they are going to be calculate the all tree. Means if I have the, see, this is one of the SPF tree, this is the one of the SPF tree. They are going to find this is the network, this is the network, this is the network, this is the network. So how we are going to be reach from one to another destination and which path is going to best. So from this point of view, if this we want to reach, so this is going to my first path, this is going to my second path. If I want to reach from there, if I want to reach from this third path, if I am the same uh, this different topology which have the all connectivity means R1, R2, R3, and R4. So from this network, if I want to reach to R2, probably I can reach via this one. I can reach via this one as well. But which one I'll choose? So definitely where SPF algorithm is going to tell this path might be closure for you, not based on the link directly connected. This going to be depend on the metric, and this metric is going to calculate based on the your bandwidth of the links. So how the bandwidth link is going to be play a vital role, I'll explain that. But it looks by seeing on this particular topology, if I am here, if I want to reach here, so this is my shortest path, but it might not be correct. It might be correct. This is your shortest path. How it is going to be done? Algorithm is going to calculate for you. Algorithm is going to calculate, and this algorithm is going to calculate based on your link bandwidth. And this link bandwidth going to help to calculate the cost. So that's why if I go and discuss about OSPF cost, yeah, OSPF metric. Anyone know that? What is OSPF metric? Any idea what is
10
OSPF
to the power of 8 divided by bandwidth, I think so.
means in layman language, what is the name, the metric of the OSPF?
Cost.
Yes, cost. Right. Cost is a metric. And how the cost is going to calculate it, that we will discuss about in the power how the formula is going to happen. Okay. But this is the metric. So cost is going to be play a vital role. And the cost is going to depend on your link bandwidth. So if you have a link, let's suppose Ethernet, then your cost is going to by default 10 if you have the fast Ethernet. Then your cost is going to be 1. If you have the gigabit Ethernet, internet, so then your cost is also going to be 1. If you have the any kind of a serial link, so that cost is going to be 64. So if I go and check in the, probably in this book also, we are going to find somewhere link cost. Okay, let me find in the see. So if you have any T1 DS link, it's going to be 64. As I mentioned that the same table which I was discussing earlier. See, serial link is going to be 64. Any serial link you have, that is 64. Your Ethernet is going to be 10 Mbps. The cost is going to be 10. Fast Ethernet 1 gigabit. So anything, if we have the fast Ethernet and above link, their cost is going to be always 1. So as I mentioned that in this topology, let's suppose if I want to reach from this source to this destination, this is my requirement, and this is my serial link. So the cost is going to be 64. This is my gig link. So cost is 1 and 1 and 1. So which path it is going to take? It is not going to take this path. It will not take. SPF algorithm is going to calculate to go by this path. Why? Because their cost is lower than this cost. So 64, and these are the just 3, 1, 1, 1, and 3. So this depend on your cost. SPF algorithm, then it is going to be check that. So I hope you guys understand how this calculation is going to happen. Now this OSPF also use the AD value. What is the AD value of the OSPF? Anyone know that?
110.
Yes, 1, 1, 10. And we know what is the AD value. AD value is the administrative distance. So if you have the multiple routing protocols we discussed in the beginning of the session, AD value play a very vital role. So if you have the multiple routing protocol running and they are having the same subnet we're reaching with the multiple routing table, so the first priority is going to be check longest prefix match. If longest prefix match is equal to all routing protocol, then second tiebreaker is going to be your AD value. If you are running the same routing protocol, so AD value is going to be same, prefix length is suppose going to be same, then what is the third tiebreaker? Any guess? Let's suppose we are running the same routing protocol in any network. Let's suppose this is the one of the router, right? This is going to be one of subnet going to receive via this path and going to receive via this path. We are running the OSPF. So if in this case AD value is going to be same, right? 1110. But you have the two path, go via this way, go via this way. So how the tiebreaker is going to happen?
Cost.
This is going to be cost. So if you have the different routing protocols for the same prefix, then your prefix length is going to be checked. If that is same, then your AD value is going to be tiebreaker. But if you have the same routing protocol, you have your prefix length is same, your AD value is same, then third tiebreaker is going to be your cost. Clear? So this is how you have to use your logic when you're going to build your routing decisions. Now, OSPF also use the one of the protocol, that is the protocol number 89. So protocol number 89. So this is the one of the protocol that is going by the OSPF. So this is a layer 3 protocol and that is going to use the protocol number. When you're going to build the OSPF use the timers. So if you have the any normal link, let's suppose you have the what I can say that Ethernet link, fast Ethernet link. So you have the timer is basically 10 seconds and dead timer is a 40 seconds. So by default is going to be huge. But if you have the non-broadcast link, right? So in that case, for the any Ethernet link, point-to-point link, this is the same timer, 10 to 40. But NBMA network, NBMA, like frame relay, ATM network, non-broadcast network, they use a timer 30 to 120 seconds. So if you go and search that timer also in the OSPF, you're going to find that OSPF timers. See, so hello interval, that is going to be 10 second. For the default broadcast and the point-to-point link, any Ethernet fast broadcast is basically Ethernet, fast Ethernet, everything is going to broadcast. Point-to-point serial link. So 10 second, dead interval is 4 times. It's a 40 seconds. If you're using the NBMA, point-to-point, 30 seconds, 120 seconds, and that is going to be wait timer also. So this is the timers we have in the EIGRP. Okay, so moving further, we have some basic idea about the OSPF. Now let's talk about the area concept. Whenever going to deploy the OSPF, they use the concept as an area. Means whenever you want to deploy the OSPF, you have to segment your network into the area. And what is the area? Area is like similar to the autonomous system we discussed in the EIGRP. So you have to create the area. Let me use this topology already we have. So you can see I have this area. In this area, I have these two routers, two interface. I have this area. In this area, we have the multiple routers. And that is area 0, that is area 11. This is a EIGRP router we'll discuss separately. This is not going to part. This is the area 22. We have this another area also. This is a OSPF area 22. Now this is the EIGRP. So we have the area. What is the area? Area is basically segmentations of your network, and you can going to just segment different area for the better management purpose of your network. OSPF, LSA flooding. And what is LSA? We have to discuss. So you can see area. OSPF provide the scalability for the routing table by splitting segment of the topology into multiple area within your routing domain. So as I mentioned, that is type of the segmentations, means dividing your larger network into the small network for the better management. Take an example. Let's suppose we are staying in country India. It's almost 1.4 billion people are staying here. And if you're not going to segment by the state, by the district, by the block, by the village, by the panchayat, so probably you are not going to manage such a big country efficiently. It's very problematic is going to happen. So we divide India as a one country. Just think of the OSPF. India is OSPF. Further, states are going to be divided as a areas. Means different area. Means we have the Delhi state, we have the Himachal state, we have the Karnataka state, we have the Kolkata state, we have the Uttar Pradesh state. So that is a different area, and within that area, further we have a district. So sub area we are going to define that within that district we have some blocks, and within that blocks we have panchayat, and then we have village. So we maintain the hierarchy. Why we maintain the hierarchy? To maintain the hierarchy, it is going to give the better administrative management. You can manage your things better way, right? So that's why we use this particular concept that is known as the area. So an OSPF area is a logical grouping of routers. So it's a logical, it's not physical, it's a logical grouping. It's not physical boundary you are going to define. No. Simply your router is going to place in the your one data centers, or might be in multiple data centers, or might be their office locations. You're just logically going to configure on the router. Hey, you are going to part of the same router can be part of the multiple area. You can see this router is part of two area, that is area 11 and area 0 as well. So this going to be part of the my two area as well. So my area 0 and area 11. So it can be even more area based on the interfaces we can configure. So same router is just connected with the multiple area. Okay. Now, what is going to happen if you're going to configure the area? If any route is coming from one area and going to another area, so the router who is passing the route from one area to another area. Let's suppose if you're learning route from this area. So you're learning route from this area and you want to pass to this area. Okay. This area. Similarly, if I am in this area, I'm learning route to here and I want to pass from this area. So the router who is making the communication between these two area, that is known as the ABR. What is known as the ABR? Area Border Router. Okay, let me write here. So ABR stand for Area Border Router. So you're going to known as the ABR, Area Border Router. So you just check it here. Probably you're going to find it. See. So uh I will discuss that area 0 and all. See, this is area border router. Sorry, BORDR border router, OSPF router connected. So what is that AVR? AVR responsibility is basically going to pass the route from the one area to another area, right? So that is the area border router. Now we have the area 0, special area that is called as the backbone area. Backbone area is very important if you're going to create the any OSPF configurations. Okay, so you must have to define one area that is a backbone area, and every other area must be connected with the backbone area directly or indirectly. What is directly? See, this router is connected with this area is connected with the AVR. AVR is connected with the this area 0. That is a directly connected area 0. So they can exchange the route. But this area 22 is not directly connected with the area 0. So you have to connect with the this area as well by using the virtual links. OSPF uses the virtual links. So there is a virtual link concept. So directly or indirectly, you must have to connect. Else, if you're not going to connect with any area with area 0, you're not going to make any communication in the OSPF domain. It's very important, guys. If you are not connected to the area 0, you cannot exchange your route to any other area. So you must have to connect directly or indirectly with the backbone area. So you can see here, area 0 called as a special area, that is a backbone area. By design, OSPF used the two-tier hierarchy, which all area must connect it to the upper area. See, area 0, because OSPF expect all area to inject routing information into area 0. It is going to act as a transit area. And area 0 advertise a route into other non-backbone area. And backbone design is crucial to preventing the routing loops. So that is the reason, if you want to prevent the routing loop and you want to communicate with a non-backbone area, you must have to pass through the area 0. If you're not going to pass with the area 0, or you're not going to connect with the area 0, you're not going to talk with the any non-backbone area, and backbone area is called as a area 0. Okay, everyone, and you can give that area identifier any number between this range, any number like area 0, area 1, area 2, anything you want to give that, you can just give that number. And this is going to be also represented dotted decimal from this range. You want to give the number, or you can give the dotted decimals also, you can give that. We can give the area ID also. ABR already understand. ABR is area border router that connect area 0 and another OSPF area, that is known as the area border router, right? So you can see this is the area 1, area 2, and they must be connected to area 0 to get that configuration. And now we'll discuss about that different packet type of the OSPF. So let me enable the OSPF first. So we'll discuss eventually the packet type also. We have the basic understanding of the OSPF area and basic SPF algorithm. Now let me discuss about their behavior, how we can configure the OSPF. So let me configure the OSPF in this backbone. Let's understand how to enable the OSPF first, then we'll discuss the packet type as well. I believe interface is already configured. So I will disable the OSPF. So it will save some time. I'm not going to configure the interface from scratch. This is there. Okay, so there are the point-to-point connectivity, same logic, 12, 1 here, 2 here, 13, 1 here, 3 here, 34, 3 here, 4 here, 24, 2 here, 4 here. These all configure, but let me say OSPF neighbor is configured or not. So let me delete the OSPF configurations. I want to configure OSPF from scratch. So I'll go here because it's an old configuration. So let me delete that. So it will save some time. OSPF is removed. Config no router OSPF 10. No router OSPF 10. And config to no router OSPF 10. So run section OSPF. Let me check we have any configuration not. No config. So run section OSPF. No config. Show run section OSPF. No config. And let me check show run section OSPF. is also going to be no config. So now we are in the plain network. Show IP interface brief. And you can just ping the all neighbor. We created one of the loopback as well. So you try to ping dot two. So its neighbor is going to be pingable. See, it's dot two means from here I'm able to ping this one, and 13.3 should be also reachable. So ping 13.0.0.0.3. I'm able to reachable. And loopback, we have the configuration here. So if I check the show IP route, we're not going to get any route here except the connected route. If I go for the this also, we not have any route, just connected route. Simple, I just have the IP address assignment on the interfaces. Clear? No other configuration we have. Here also I'll go that. Simple IP address assignment. Now, if I want to enable the OSPF, so definitely, as I mentioned that when I have to enable OSPF, the routers are going to exchange the packets, and that is the OSPF packet. They are going to exchange the hello packets. You can see there are a lot of packets type we have. Where it was, if I go a little bit down, so we have the hello packets, we have the database packet, we have the link state request packet, link state update packet, and link state acknowledgement packet. So when I send the any means when I going to enable the OSPF on the any routers. So what information they are going to exchange? So definitely they're going to exchange the hello packet. And in hello packets, we have the multiple type of informations. And if those information is going to match, then only they are going to be establish the neighbor. So whenever I'm going to enable the OSPF, let me go here and try to do that. We'll see in the debug as well. So I'm in the router one, and now OSPF can be enabled in the two types. One is the global mode. OSPF can be enabled in two way. First in the global config, second in the interface based. So I will show both of them. Once I will configure the global, and one I show you the your interface way as well. So you will understand both of them. So how to enable the global way? You just go in the config T, right? Before I enable, let me enable debug IP OSPF packets. Okay. Debug OSPF. Sorry. 10 process ID. I'm going to use the process and hello message. Okay, so this is going to say that. And debug IP OSPF events. Let me use the hello as well. Okay, so show debug. You see, I enable the debugging for the hello packets and packets. So this debugging is on. So now I'm going to enable the OSPF configuring, and I use the router OSPF. Once you configure the router OSPF, you have to give the process ID. This process ID is important for the Cisco iOS. SD-WAN might you not going to use the process ID, but Cisco iOS it's very important to use the process ID. So how process ID is going to play a role here, I will discuss about that. But one thing you noted that this process ID is never going to exchange in the hello packet. Hello packet is going to carry a lot of informations. Likewise, router ID, hello indeed intervals, neighbor details, area ID, router priority, your DRBDI information, authentication, passwords, authentications, password, and stub routers flag if anyone have. That all is going to be there. I'll going to write it here, but for time being, just understand we are going to configure the process ID, and this process ID is local to the router. The process ID is 10. If you have any VRF, you can use the VRF keyword. We don't have the VRF, just hit enter. Now, we are going to enable the OSPF on the two networks, means globally 12.0 and 13.0. So I'll go here and put the network 12.0.0.0, and you have to give the wildcard. So wildcard is /24 subnet This is a wild pass, and you have to give the area. And what is area? This is my backbone area. So area 0 is going to be there. This is my backbone area. So I'll put as a area 0. So I'll give as a area 0 here. Done. Now, see, the moment I configure this network, see this debug message. Hello packet has been sent. You can see, but there is an address. What is address? You can see here. Okay, let me configure one more network. Then I'll explain these packets. Okay, so this is the second network I configured, and see, again, hello packet has been sent. So let's understand what is this message and what is inside of this message. Okay, so let me exit and UL undebug the packet. Now let's understand. Whenever you're going to configure the OSPF, guys, okay, you're always going to send the hello packet. That's the very first packet in the OSPF. This is the very first packet in the OSPF, and this packet is going to carry multiple informations. What is that information? Let me configure. This is going to configure your carry your router ID. Okay, this is going to carry your hello and date timer. Okay, you can write this all information. What is the hello and date timers for the Ethernet link? Anyone able to recall? Hello date timer.
30
Yeah,
timer.
10 and 40. Area ID. Okay, router priority. Right, we have the DR, BDR details. What is DR, BDR? We'll discuss about that. We have the any authentication. If we have the any stuff,
Tilda.
stuff flags, that is going
No,
to.
Ranga. Hmm,
Sorry, Amrita?
hmm.
Amrita, anything you asking?
Sure, okay.
Amrita?
Sorry.
Okay, that's fine. So this is the hello packet. Hello packet is going to carry these all informations. Okay. Now you see one more information. This is the hello packet is going to carry this information. You see one more information. What is this? I never talk about this. We talk about the area ID. This is the area 0. This is the router interface ID. But what is this? Okay.
Multicast address 5 and 6.
So this is never talk about that. So whenever you're going to be define, everyone can note this down. Whenever we're going to define any kind of the OSPF, right? OSPF is going to use the two multicast address. Okay, the very first you saying here, that is a 224.0.0.5. That is going to be joined by or listened by the all routers. Means every routers must going to listen this multicast address. This is the multicast address. That is a listen by all router. There is one more address 224.0.0.6. This is going to be listened by only DR routers, designated routers. So I will discuss what is the designated router, but just take a note. We have a two multicast address. So right now this is not designated, this is a normal router, and this is going to be listened by the all routers. Means sorry, 224.0.0.5. This is going to listen by the all routers. And if you have any multicast address like 224.0.0.6, that is listened by the only DR routers. So every time, whenever going to enable the OSPF, the router going to join this multicast. And if any other are also join this multicast, they will going to listen and they will going to form the neighborship. So this is only two takeaway we have. Area, hello, what is the hello packet is going to carry? That's the information is going to carry with the hello packet. This is the multicast address. And this is the area. You can see the similar information also. Send hello, but we are not getting any reply. You get the send hello message here. There's a multicast, and we are done. Now, one more thing we're getting here. We never configure any router ID. See here, router ID. So This OSPF hello packet also carry the router ID. So what is the router ID and how this router ID has been calculated? Anyone know that? I never configured the router ID in the OSPF. So the loopback, if available, that is going to become my router ID. So my loopback 1.1 is configured in my router. So that has been become my router ID. If this router ID I want to define the explicitly, I can do that. But if I'm not defining the explicitly router ID in under the OSPF configuration, how we can define? If you want to define the router ID explicitly, if you go here configuration and you can configure router OSPF 10 router ID, you can just give the explicit router ID. Then this will come as a your defined router ID. But if you're not going to define any explicit router ID, then it will take as a loopback router ID as a highest router ID. But what if there is no loopback configure? Then which is going to my become router ID? Anyone, any guess? Let's suppose there is no loopback, then who is going to become my router ID?
Highest interface IP address.
Yes. So if there is no router ID configured, I mean manually not hard coding the IP address, there is no loopback interface configured, then third option we have to use the highest configure interface loopback, interface IP address. So this is how you have to remember these things. Okay. So now we understand the hello packets. Everyone understand what is inside the hello packets? Clear to everyone? You can just Google it, you can search it, you can make your note it. Now, this is a hello packet. So every time when you're going to build the OSPF, they are going to send the hello packets. So packet are sent periodically to all OSPF interface, discover the new neighbor when ensuring that there is a neighbor are still online. So it's going to keep sending the hello packets every 10 seconds. Hey, you are alive or not alive. And these hello packets are going to exchange a lot of informations. Based on that, hello packet, they are going to form the neighbor, and after forming the neighbor they become the adjacency. So one more thing always you have to remember in OSPF, okay, there is two term you are going to find in OSPF. This is the R1, this connected with the R2. First you are going to find as the neighbor, right? Second term you are going to find as the adjacency. So it's not necessary my this router is going to my neighbor, but it's also adjacent. Adjacence and neighbor have the two different definitions. Neighbor cannot be your adjacent. Adjacence can be your neighbor, or 100% that will be your neighbor. So what is that means? Adjacence and neighbor. Neighbor is, let's suppose I am the R1, you are the R2. We having a two flats. Okay. But I configure the OSPF here. I configure the OSPF here. But my OSPF having the hello packets and they carry the multiple information inside the hello packets. But they are not matching. So if they are not matching, we still join the same multicast group. Everything is fine. We are the neighbor, but we are not adjacent. To become adjacent, I need to match the hello packet informations. If it is not matching, I will not be your adjacent. If I am not adjacent, I will not share my database DBD packet. DBD packet. I'm not going to share you. So you can think about it. You have a true house, house 1, H1, and this is your neighbor house, house 2. This is the condition 1. There is a condition 2. This is the house 2, sorry, house 3, and this is the house 4. Technically, they are neighbor. This is the neighbor. This is the neighbor. But these two are very good friend. They coming house every day. Their kids are playing in this house every day. They exchanging the food, right? They sharing their thoughts. They're going on the holidays. Means they are very good friends, family kind of things. They are neighbor, but they have the full access of the both house. These kids are coming in this house, these kids are coming in this house. They have the very good family relation and all. They also neighbor, but they don't like each other. So they will never going to exchange food. Their kids are never going to be come inside the house. They always keep in fighting mode. So these neighbors are actually adjacent, means they are exchanging their information. But these neighbors are not adjacent, means they are the technically neighbor. They also neighbor, but they are not good friend. Okay, so same logic OSPF use. Okay, so don't be confused. Somebody ask what is the difference with the adjacents and neighbors? You should know about this. What is the difference between adjacents and neighbor? So adjacency is a process when you are qualify the all neighborship criteria, means adjacency criteria where you form the hello packet exchange between the two devices. So if all hello packet information are going to match, then you are going to become from neighbor to the adjacency, and then you are going to change the database. So this is another packet. Database description. The packet exchange when it's not talking neighbor, when an OSPF agency first being formed, not begun. These packets are used to describe the content of the LSDB, link state database. So it's not going to exchange OSPF database in term you are going to be neighbor. No, neighbor cannot be adjacent. But once you become the adjacent, you are the fully qualified neighbor to exchange the DBD. Clear everyone? Hello and DBD. I hope it's clear to all. Okay, now we have the further packets that is known as the LSR, LSU, and the LSA. So what is the link state request? Link state request is a request. It's again a packet type. When let's suppose you are going to lose any route information, router link, think that part of LSDB is tell, or you will lose the configuration, you lose any kind of the neighbor database. So it is going to request LSR, link state request, and based on the link state request, any router know about that particular route information. In the OSPF, any network is going to be advertised. They are going to be known as the LSA, link state advertisement. Means anything you're going to advertise in the OSPF, that is the LSA. So we are going to focus much in the LSA later on, link state advertisement. So LSA are going to be your network link informations. Any network information are going to be basically advertised from one neighbor to another neighbor. That all are going to be basically requested by the LSR. LSR is going to request, and based on that, LSA information is going to be provided to you. So based on that LSA information, you are going to be form the your that complete informations in your database. So what is going to happen? LSU is the send the specific link state whenever going to be required and in form of the LSH. And based on that, once LSH is going to reach to you, you're going to maintain your new database. And then after it will acknowledge, means anything is going to be request is going to be happen, update is going to happen, then your router is going to acknowledge, yes, I received that and we are good. As of now, we don't require any other things. So this is the packet type, right? And by using this packet type, let me go here and search here OSPF packet types. So hello is basically they're going to join this multicast. DVD is the exchange summary LSA we discuss. This is a unicast packet going to send to the your peer, adjacent peer, one-to-one, and link is a request detailed information about the specific or missing record found during the LSDB exchange about the route we are talking about. Based on this request, LSU is going to be the link state update is going to happen. That is a link state advertisement. LSA is going to be there in the picture. That contain the detailed routing and topology data. Simple means any routing information is going to be updated to you, and based on that, you are going to be explicitly acknowledge, yes, I received that informations. We are good to know, and they are the packet type. Okay. Now this is the database. Okay, this is the packet type, and this is already discussed. Okay, we are good till here. So we understand about that packet type. We understand about that Area type, we'd understand about the basic logic. Router ID, we understand. Router ID is basically OSPF. And if you're going to define explicitly, you can define the router under OSPF process. You're not going to define, then it is going to take the loopback address, right? If there is a loopback address, then it is going to be take. If there is no loopback address, the highest IP available on the interface, it's going to be configured. This is also written here with the loopback address. Okay, now we discuss about this one also. OSF hello packet going to configure the router ID, authentication, area ID. This all information we discuss about that. Hello interval, data intervals. You can find in the also in the book as well. What is inside of the OSPF hello packet. So this discuss also. Now, when you talk about the OSPF have the multiple stages. Means if I talk the multiple stages, means multiple steps you have the OSPF. What is that the states? Means when you're going to configure the OSPF, you can see here we configure. Let me build this neighborship, okay? So now you can see if I just run the show IP OSPF neighbor, right now it's a down state because it's trying to be form the OSPF neighborship, but it's not going to form. So when we're going to step configure the OSPF, it is going to be in down state. And further, it is going to be initialization, 2A, start, exchange, loading, and full. Means they are talking about when I'm going to configure the OSPF between two router, what all states are going to become before it's going to be my fully functional OSPF neighborship. What all the states are going to become before it's going to be fully functional my neighborship. So that is known as the OSPF state. So this is my OSPF state. So you can see this is a down state, attempt state, init state, 2A state, start state, loading state, and full state. So probably you're going to always find your OSPF neighborship in the full state. Let me show you. But before going in the full state, OSPF neighborship is going to be in the multiple state. And let me show you these all states, how it is going to be happen step by step. Let me close this. So now I configure the OSPF. You can just see show run section OSPF. And now let me debug IP OSPF. Hello. And debug IP OSPF adjacency. Okay. I will events. Okay. So show debug. Debug is on. So it keeps sending the hello packet. You can see it keeps sending the hello packet on two links, but nobody's replying right now. Nobody's replying right now. So I will go on this router and I will try to configure the OSPF. And eventually we'll go on this because this router is sending the hello packet on these two links, but these are not part of the OSPF. So right now it's not replying. So right now this router is acting as an init state. So if you technically see, we are trying to attempt is not used for the it's especially used for the NVMe network, so you can ignore this one. It's now in the init state. I mean, this router is trying to initiate the hello packet, but nobody is replying. So you can see here it's written as the init state. Hello packets being received from the other router, but bidirectional communication had not been established. So might be receiving. Anuj, you was saying anything? Anju?
Hello, sir. Good morning.
Sir, good morning. Good morning.
Yeah. Yeah, this is my trial class.
Okay, that's fine. Thank you. Welcome to the class. All right.
Thank you.
So in this, basically, you can see in this stage, in hello packet are received from the router, but bidirectional communication not be established. So it's going to be not only receive, also it's sending. It's trying to initiate the neighborship, or might be a receive somewhere, but still I not able to form the full adjacency. So I'm just trying to initiate the connections. So even I'm sending the any packets, or even I'm receiving any packet, that's all are going to part as the my init state, that is hello is being sent. So now I'm going to configure this router and I want to make sure this also going to be initiate the connection. So I'll go here, configuration terminal, and after going in the configuration terminal, I'll go and configure. Shall I go in the global or link? Okay, let me configure link base this time. So I'll go on the, earlier we configured the global mode. Now I'm going to configure the link mode. So interface gig 0x0, IP OSPF 10 area 0. And the moment I will configure, let me first enable debug also here also. Wait. Debug IP OSPF. Hello. Adjacency. And what one else? Events. I'll configure the events as well. So debug. Okay. So now let me configure the OSPF. Interface. I'll go on the my gig 0x0. IP OSPF 10 area 0. The moment I will press enter, you will see this is normal log we are getting here. This is normal log I'm getting here. But the moment I will hit, you will see the logs are going to be immediately converged in the different methods. Wait for a while. See here. See this all magic. What happening? So let me stop this. You all. Okay, so it captures this log, and here also you can let stop it. Now try to understand this. What happened when I configure this neighborship from this to this, only this to this. I have flood of the logs, but try to decode these logs. So see, the very first statement, send hello packet on this router and you receive hello packet. Earlier it was not receiving. So you receive the hello packet and your two-way communication has been established. Okay. You start DR BDR election. You elected first BDR and then DR. In interview, it is going to ask, who is going to select DR or BDR? What is the answer, guys? What is going to select first, DR or BDR? Might be you don't know what is DR and BDR, but in interview, if you're going for the interview, they will ask that in OSPF we have the DR BDR election, designated router and backup designated router. I'm going to talk about that. Who is going to select first? Most people fail here. Most people tell that DR is going to elect first, but that is the wrong answer. Your BDR is going to elect first. See here. And then your DR is going to be elected. Make sense? And then you can see after DR BDR election, we have the exchange the database and then send DVD and all. And then your neighbor event change. So you can see these all informations. And then you have the negotiation via slave. You can see here also slave master slave selections has been established and we are exchange done and you are in the synchronization in full state. So these entire packets are explaining this table. Full loading, exchange, start, two-way, init, and down. So this is your stage. I'm just showing you everything. Let's understand one by one. What is that? So down state means when I talk about down state, in down state, initially we don't have any kind of the neighborship between the you and me. So we are going to be down, or I'm just going to start the hello packet, but nobody is going to listen to me. So I'm just trying to initiate the hello packet, but nobody is responding to me. That is a down state. Attempt is not applicable because we are not using this NVMe network. There init state means somebody is trying to send me packet, but still we not have the neighborship. That is the init state. So earlier we have the init state. This is called as a init state. Hello and receive. Now after that, we have the two-way state. Two-way state is basically it's going to be bidirectional communication is going to be happen. In this communication, we are going to select the DR and BDR. And why DR BDR is important? Say DR is basically designated router and BDR is basically backup designated router. So DR is basically a router who is going to maintain the LSAs database. Means basically everyone is going to send the, I'll explain explicitly in after this lecture what is DR BDR, but I'm just giving the brief. Means every router must have to synchronize the database with the DR, and in case DR is going to fail, BDR is going to back up for that DR. So to minimize the LSA flood in the OSPF network topology, we have to select one router, the DR and BDR. So every router is not going to send the all routing information to each other. So it is not going to be spike your CPU utilizations, your memory utilizations. So to prevent that situation, you have to use the DR and BDR concept. And this where DR and BDR is going to be basically establish the connections. So it's going to maintain the and minimize the flood of the LSA. So I'll discuss about that explicitly how it is going to happen with example. So wait for a while. So two-way, if you go in the two-way state, you can see here's a two-way state. See, two-way communication. In two-way communication, they are going to select the DR BDR. And who is going to select first? BDR is going to select first, then after DR is going to select first. This is your DR BDR selection process. Okay. And after that, they will go in the start state. In this start state, they're going to select the first state in the forming the adjacency. Means this is the start state is going to first state the forming the adjacency. Means you are the neighbor, but still how you're going to become adjacency, that is the start state is going to decide. Router identify which router will be master or slave for the LSDB synchronizations. Means you are going to be part of the adjacency. So who is going to transmit the data first? Means there is two routers. This is the R1 and R2. They are the neighbor and adjacent. But who is going to transmit data first? So they are going to decide who is going to master, and master is going to transmit data first. Once it is going to transmit, then slave is going to exchange data. So that has been done in this event. You can see here, there is the neighborship negotiation done and we are slave. So this router declare that I am a slave. So if it is a slave, there is one master also. Where is master? You guys able to see master somewhere or not? Okay, so little bit might be master information is not available, but you can say we are slave. So by default, one is going to be master. So one is going to declare I am a slave. So the slave one is going to be slave is basically this is the DVD, this is the slave, and this is going to be master. If this is slave, then this is going to be master. So master is going to be initiate a data, right? And then your master will exchange all database, and based on that, your slave also going to exchange database. And once they're going to exchange database, then they're going to be exchange that informations. All expensive DVD is going to be exchange in this stage. Exchange state, they're going to DVD exchange, you can see. And then they are going to be loading state. So this is the loading state, loading to full, you can see. So they are going to be loading state. Loading is basically they are going to be complete state for the LSR, means a state which LSR packets are sent to the neighbor asking more information. Means in loading state, if you missing any information from the neighbor, you want to get those information, so you just send the LSR packet. We discussed the packet type. So it is going to send the LSR packet. Hey, I want to more informations. Based on that, it will supply the LSU and then acknowledgement. Then you are going to be get the all informations, and then you are going to be in the full state. That is a fully synchronized. So technically exchange to full is going to be state, but in case if any route is missing, then it's going to loading state, else it is going to be full. So you can see technically we're in the loading and then we're in the full stage, and then your database is fully going to be synchronized. So this is the state of the OSPF, and same thing you're going to get here also. You can see this is the master. So master and slave. Yeah. Here it's declare I am a slave, and this router declare yes, this is the master. So you can see I was not able to see the log in the same router because this was a slave only. Themselves he declare I am a slave, and he declare this neighbor is my master. So you can see this is a master. So he is going to initiate the full synchronization and everything is good. Synchronized. This is the state of the OSPF. Clear, everyone? What is the state of the OSPF and how a state is going to form? So not theoretically, I just show everything practically as well in the debugs. Okay. So this can be one of the depth class ever I have taken about the OSPF, about that showing the everything with the live examples. Okay. So hope you guys understand this concept as well, how this is going to be happen. Okay, so this is like down state, init, two-way, start, exchange. This is loading fail. One more thing you might be going to be see here. See, this is the MTU size. Why you saying MTU size? They are going to match if you're going to configure any OSPF neighborship. And let's suppose your adjacency stuck in the start state. Most of the time, your neighbor is going to be stay in the start. Right now, if you see in the show IP OSPF neighbor, this is in the full state, DR BDR. Okay. Here also see show IP OSPF neighbor. It's going to be BDR, but it's a full state. But let's suppose I'm going to play around. If I'm going on the interface and gig 0 by 0, let me turn on the okay. Okay, I will do that later. Interface gig 0 by 0. IP MTU 1400. Clear IP OSPF process. Yes, you'll see that. After this, your OSPF is going to stuck in the see. Your OSPF is stuck in the extra state. It will never going in the full state. Exchange, BDR, but they are not going to form the adjacency. We are the neighbor, but we are stuck in the start. Why it in the start extra state? Most of the time, people are going to ask these questions when going to troubleshoot the OSPF. Hey, your OSPF is stuck in the extra state. What could be the issue? Any guess? Anyone have? Then how to check that? So let's have a debug. Debug IP OSPF hello packets. Hello, I will go and check the adjacency, right? And I will check the events. See, you're getting some logs. Anyone able to see that? What is the log?
It
Anyone
says
able to?
larger MTU on 1.1.1.
Yes, so you can clearly see MTU 1500 at a start state, and your neighbor has the larger MTU. Clearly, it's showing that neighbor have the larger MTU. For myself, what is my MTU? 1400. And for there, by default, MTU is going to be 1500. See, default MTU is basically 1500 for this interface because we not have any configuration. So by default, it's take the 1500. So that's why you are never going to be formed the OSPF neighborship. It's stuck in the exchange state, and here is stuck in the show IP OSPF neighbor. It's a again it's going down. It's going to be like probably any state DR other. It will going to again in the start state. So MTU is basically a process where MTU is going to be mismatch. Your OSPF neighbor is going to be stuck in the start. It's showing the too many retransmission. So if I want to fix this value, so I simply go here and IP MTU 1400. Let me run the debug all. Debug IP OSPF. Hello. Adjacents. Events. So let me do that. See. So the moment I have done, again they form the neighbor. So MTU also you can see now this time MTU has been negotiated from the 1500 to 1400. See. And based on that, you are having the neighbor. Show IP OSPF neighbor. Clear, everyone? This is clear. M2 we have here in the neighborship. Okay, so now we understand this also concept. Now let's understand what is a DR and what is a BDR and why you use the DR and BDR in the OSPF. Okay. So DR is basically a designated router and BDR is the backup designated router. So as we've seen in our topology, DR is going to be elected not first, BDR is going to be elected first and then DR is going to be elected. So let's suppose this is my topology. This topology, we have the multiple routers, R1, R2, R3, R4, R5. This all might be connected. Okay, everyone is connected. So let's suppose once they connected, they use the concept of the LSA, link state advertisement. Take this note, LSA. We have to do the deep discussion on the LSA. Link state advertisement means any network is going to be inject from this router. Let's suppose this is my 10.subnet /24. This is my 20 subnet. This is my 30 subnet. This is my 40 subnet. This is my 50 subnet. Take an example. So what is going to happen? They immediately going to inform the neighbor, hey, I have this network, this network, this network. Everyone is going to tell their neighbor, hey, I have that much network. So you can see how many LSA flood is going to happen. So every information, every network is going to be inject in my routing table. They all are going to have the too many LSA flood. And if the LSA flood is going to be happen, then what is going to happen? Your performance of router is going to be degrade. So if you talk in OSPF, why we use DR and BDR? So you're going to get this simplified definitions. We use designated router, backup designated to solve two critical problems in the multi-access network. Excessive neighborship relation and flooding of overhead. Might be this language is little bit very professionals, but in the layman, you just minimizing the LSA flooding. Means without DR, BDR, what is going to happen? Every router would have formed adjacency with each other and causing network to shock on redundant background traffic. Like it's again very high level language, but it's going to be like if you have the multiple explain in easy way. So let's get the good examples. So everyone try to talk to each other, right? Same time. Person means they're going to. So everyone going to send the every information. So DR is going to act as a boss, and that is a backup boss, assistant. So in this DR BDR, what is going to be happen? Everyone is not going to send information to all. No, it's not like that. Instead of that, what is going to happen? In this router, we are going to select one router is going to be DR and one is going to be BDR. So let's suppose this is my DR router, this is my BDR router. So everyone is going to send the LSA information to DR, and if DR is going to fail, then BDR is going to be come in picture to take the DR role. And other router means who not going to part of the DR and BDR. They are known as the DR others. Means this is known as a DR others routers. DR others routers. Right? Clear? So DR is basically role to everyone have to send the LSA informations to the DR, and BDR is basically backup data. So you go in here and find that passive interface will discuss that. Let me see if you have the DR BDR. So designated router, backup designated router, electro multi-access network. Again, they are giving the same. So primary router responsible to managing the routing information, flooding link LSS. All other router on the multi-access means any multi-access network means Ethernet network. You are going to get the DR router who is going to responsible to flood the LSA information. Everyone is going to give the LSA information and he is going to responsible to further give the LSA information to its neighbor. Backup designated router act as the hot standby. It form full adjacency with all neighbor as well. Will immediately take over the DR role in case of the active DR fails. DR others is basically all other router who are not going to part of DR and BDR, they are going to consider the DR others. So these all are going to be DR other. Now the question is, how you elect the DR and BDR router? How we are going to elect the DR BDR routers? There are two major conditions. If the router having the highest priority, if let's suppose we configure the explicit priority for the router to become DR BDR, then it's going to be DR router selected. But if priority is same, then what is the second tiebreaker? Second tiebreaker is because your router ID. So router ID basically you're going to explicitly configure the router. Highest router ID is going to become my DR BDR condition. So let's test this DR BDR, how it is going to be formed. So now let me ask one question to everyone. It might be tricky questions and it is going to ask in the interview as well. In this network, this is the 4 routers. And these all are the gig interface, Ethernet network. See, this is the one subnet, this is the one subnet, this is the one subnet. So how many DR BDR is going to be there in this particular 4 router? How many DR BDR? Anyone?
One DR and one BDR.
So technically, one DR and one BDR. It looks. Any other thoughts anyone have? In this, I have the 4 links, the 4 different segments, 4 different kind of the subnets. So the question is how many DR BDR is going to be selected here. So I get one answer, one DR and one BDR. Might be this router is going to become DR, this router is going to be BDR, but only one. Any other thoughts anyone have?
Different networks or different DR and BDR,
Okay,
as
so
it has different subnet, four subnets.
so
of
you're saying
4.
that for this network have the separate DR, this
Yeah,
network have a separate DR BDR, this having a separate DR BDR, this having separate. Total how many? 4
4.
DR and 4 BDR. Okay. What about this, guys? How many DR BDR for this particular network? See, they are in the same subnet.
So that depends upon the area. I mean, if there's one area will have a one DR, one BDR.
This area 0, let's suppose.
One DR, one BDR.
1 DR, 1 BDR. So as per Binay, this area is area 0. So as per you also 1 DR, 1 BDR, right? Binay, is it right?
Yes, yes, yes.
Okay, let's test it. And take this note, ask your colleagues. I'm sure they will never going to answer this query. Ask this question to any of your experts. Very difficult. If someone have the good OSP of understanding, they only answer these questions. Else they will not ask this question in case of DR BDR. So let me configure this. Let me go. This switch we are not going to do any configuration. So let's have the fun activity now. That will make 18. Why it will make 24? So config T host name, this is going to be R1. Config T host name, this is going to be R2. Config T host name, this is going to be R3. Okay. So simply I'll go interface. What is the interface? This is my gig 0 by 0. IP address 192.168.1.1. I'll configure the OSPF on the interface level. IP OSPF and area 0. Okay, do right. Simple. I'll go here also. Interface, that is going to my gig 0 by 0. IP address. This is going to be 192.168.1.2, 55. No shit. IP OSPF and area 0. Pro right. And I will go and configure on this interface gig 0 by 0. IP address 192.168.1.3, 55.55.55.0. No shit. IP OSPF and area 0. Right. Okay. Show IP OSPF neighbor. So they are forming the neighborship. Wait for a while. Wait for a while. Unless they're going to fully converge. It will take time. Little bit. So finally we have the neighborship. One neighbor is up. Still one is stuck in two-way state. So they form the neighborship. Right. Okay. So now tell me, which is my DR? Can you tell me someone which router is my DR in this topology and why? Which router is DR and why? Try think,
Dot
guys.
3, dot 3, sir.
And why?
Highest IP address on that interface.
So the criteria is router ID. So if there is no router ID, what is the default router ID? Sorry, I asked the wrong question.
Loopback.
Sorry.
We haven't configured the loopback.
Priority. Sorry, priority. What is default priority?
The
0.
loopback is the
No, default priority is 1. If any router having a priority is 0, they will never going to participate for DR and BDR elections. Okay, that's also not. So if you say here, see, every neighbor having a priority 1. Clear? So default priority is 1. So if we want to change the priority, then priority more than 1. If any router having a priority more than 1, so that will become my DR and BDR. If there is no priority, how to configure the priority? Let's suppose I want to configure the priority. So configure terminal router OSPF 10 priority. I can just make as a 20. Right. So clear IP OSPF process. Wait for a while. So once I'll change the priority, now you'll see the magic. Show IP OSPF neighbor. Still, let's not change the SPF. This is the command. This is the command only. Why it's not changing? Okay, sorry. I configure on the OSPF on the interface level, so I need to change in the interface level. Sorry, let me change in the interface level. But in the global also, IP OSPF. No, it's not supporting priority. Okay. It's a configure for entire topology priority. So I need to configure on the interface level. Let me do that. So I will go here and my interface is gig 0 by 0. IP OSPF priority. I can change the priority. Let's go 20. And now here IP OSPF process. If you're changing anything, make sure you clear the IP OSPF process, reconverge, then you'll see that. Now check it. Show IP OSPF neighbor. We are not configuring the global. So now I'm still not changing it. Okay, let me clear this one also. Clear IP OSPF process. Actually, I need to clear the all DR as well. DR is not leaving his role. So clear IP OSPF process. So let's wait for a while. Let's wait. The DR is still not elected. See, now your DR. So I forgot to clear even I configured that also was fine. That priority also was fine when I configure the globally, but I need to clear the DR OSPF process. So it will reconverge. Else it will still going to be part of the DR. So now you can see now my router 1 is become a DR. Why it's become a DR? Because it's become my higher priority. So if there is priority, then it's going to be first criteria. If there is no priority, then router ID, if it is configured, if there's no router ID, then it is going to be take as your interface IP address. But in this topology, we have single DR. We all agree? And for this router point of view, right, these two neighbors I have. One is the DR other and one is the BDR. Why it's become BDR, guys? Because it's have the highest router priority. So it's become my BDR. You can see. This become my DR other R2 because it's not participated DR and BDR, so it's become DR other. And you can see for this router point of view, my neighbor 1 is my DR and my neighbor 3 is a BDR. If I'm going my neighbor 3, show IP OSPF neighbor, we have my R1 is a DR and R2 is a DR other. So clear, in this topology, we have one DR, one BDR and one DR other. Everyone understand how to calculate DR BDR in the one, but notice that this is the one segment only. This is the one segment. Now let's go on this particular topology and understand how DR BDR is going to be elected. So if I'm going there, if anyone have any doubt, just let me know. Show IP OSPF neighbor. Why I lose the neighbor? Show IP. Okay. See, we having a DR, and if I go here also and show IP OSPF neighbor, saying that my neighbor is BDR. This neighbor is BDR and this neighbor is my DR. Okay. Why? Because this is the highest IP address for this link only. Okay. So if I just configure the R3 as well, you will see the magic. If I go, I can configure interface range. I'm going to enable the OSPF on these two interfaces, gig 01 and 001. So let me configure on the both 0 by 1 and 2, both. And IP OSPF 0 area 0. Do right. Done. And I'll go for the R4. R4 also I'll configure on these 2 and 3. Let me go in the R4. Interface range 0 by 3 and 4. Sorry, 2 and 3. IP, OSPF, 10 area 0. Do right. And I'll go for the R2 as well. And configure it. Interface. 0 by 3. Area 0. Do right. Show IP, OSPF. Neighbor. You can see there's 2 neighbor. Show IP, OSPF neighbor. There's 2 neighbor. Show IP, OSPF neighbor. So let's wait to fully converge. Six start state. Show IP, OSPF neighbor. This is fine. This is still, yeah, this is also fine. This is also fine. This is also fine. So what do you guys think? In this area, we have how many DR and BDR? In this area, the subnet are different, okay? And you guys see here, every segment have their own DR BDR. You can see. For this R1 point of view, you see that for this link, this is my DR. My neighbor is DR. And for this link, this is my neighbor is a BDR. So I have this DR and this BDR for this two segment. For this segment, this is a DR, this is a BDR. If I go on my R3 now, you can see if R3, if I go in that, you see that it's saying that for this link segment 1 by 1, see, this is my DR. My R1 is DR. For this link, this is a DR, but this link, this is a DR. And this is my BDR. Who is my BDR? This R4 is also BDR. And if I go for the R4 now, you see it's saying that these two are DR for me. Means for my point of view, these two my DR. See? So every link they have on DR and BDR. Binay, makes sense to you?
Yeah, yes, I got it. So each segment will have one DR, one BDR. So total 4 DRs and 4 BDRs.
Yes. That's why it's very many people are always confused and just they are DR, BDR only one per area. No, it's not like that. You have to think about the what is subnet. Is subnet you have one DR, one BDR. Okay. So I hope you guys understand about a DR and BDR concept fully. So you can see here if you go multi-access network, primary responsibility managing, and might be set as some. Okay, leave it. So you can read it. So you can see like Ethernet prevent the network congestions. So each segment we have.
But sir, I have never seen this type of topology in like enterprise networks.
Which type topology?
Um,
This type.
yes, correct.
Yeah. So that's why I'm just representing now. In LAN, you must be seeing this kind of topology. You might be have the multiple switch. Okay. They connected with the router and they have the same same subnet management IP address. So you can be fine. I have seen this kind of topology, but not very frequently. So in that you can find that everyone have the same management IP or same kind of similar same subnet LAN IP address, and they all are forming the OSIP adjacency. Generally, we find this kind of topology.
Yeah, okay.
All right. So everyone, okay? Any doubt till here? Okay.
And
So
sir, let's say if we in that topology of four ring topology, if for let's say router one, router two, we running OSPF and we give them a command of point to point, then there will be no DRBDR, right?
yes, there is no DRBDR selections. So DRBDR is only going to selected in the your NBM, your multi-access network. There is no point-to-point. Point-to-point network. Let me bring that diagram. Okay, multi-access network, you're going to select only DR-BDR, broadcast multi-access, point-to-point, there is no DR-BDR network in the point-to-point or multi-point, point-to-point or point-to-multi-point. I need to find that, but yes, you can just Google it, you can find it. Point-to-point network, and how to configure the point-to-point network, we'll discuss about that. So you can see we have the network type. This is the next point-to-point, point-to-multi-point, not broadcast. So if you're going to configure any network as a point-to-point, let's discuss about this as well. So you're going to find no DR-BDR. How you can configure it? Right now, this network is basically gig 0 by 0. So this is the Ethernet multi-access network. And if I go in the R2 as well, and if I go in the configuration terminal, this is the multi-access network. Now, in this network, we have the DR-BDR selection. But if I change this network as a point-to-point, so if I going to change as a interface, sorry, IP OSPF network type, network point-to-point or point-to-multi-point. By default, it's a broadcast. That is known as a multi-access network. If you're changing the point-to-point network, see, neighborship is down. Why neighborship down? Because they just mismatch of the your network type. So now I'll go again, configure the here also as a network type as a IP OSPF network point-to-point. Now you'll see again it is going to fluctuate and it's going to be there. Now if you go and check show IP OSPF neighbor, see, Bina, there is no DR-BDR. So in this network, we are not having any DR-BDR selections. So in the point-to-point, you have the any network point-to-point and point-to-multi-point. And how to change the point-to-multi-point? To change the point-to-multi-point, again you go on the interface gig 0 by 0, IP OSPF network point-to-multi-point. You change it from here. See again down and you go here, select the point-to-multi-point again. So now your network has been changed. But still you're going to see here, show IP OSPF neighbor, there is no DR-BDR selection. So only DR-BDR is going to be selected in case of you have the broadcast. If you're changing the NBMA network also, non-broadcast network, let me do that also. So if I go here, interface gig 0 by 0, IP OSPF network non-broadcast. Okay, done. See, this is down and this will never going to become up. See, earlier I was changing from the broadcast to point-to-point, point-to-multi-point. It was going down, it was coming up. You know why? Anyone notice this? Why? Did you guys notice? If I changing my one-side network as a broadcast, one-side point-to-point, still my neighborship was forming. But now if I change the NBMA, it's not forming. If still that time also we have the network type mismatch, but we are able to form the neighborship because your timer was same for this one. What is hello timers? 1040. For this one, what is the hello timers? 30120. So if your timer is going to mismatch for any reason, they are not going to form the OSIP neighborship because hello packet going to carry the timers. So if I go here also and change the gig 0 by 0, IP OSPF network non-broadcast, you'll see you have the neighborship very soon it's going to be there. Show IP OSPF neighbor. It's not forming neighbor. Why? Gig 0 by 0 and gig 0 by 0. Okay, let me try to shut this interface. I believe NVMe is not supporting this link. This link is not supporting NVMe network. Okay. Okay, now it's okay, fine. Let's see that. Let's wait for a while. So what I was trying to, it will form the neighborship, it will take some time. Okay. So if you have the any NVMe network, okay. So if you have the any broadcast network, NBMA, sorry. If you have the broadcast network, NBMA network, you are going to find DR, BDR concept. If you have any point-to-point network, point to multi-point network, no DR and BDR. Clear? So this you have to take a note. Then how to change that? I just show you how to change network type. So it will take, see, it's a start a state. It's going to very soon because it's slow protocols will take time to just form the neighborship. Okay, so this is done. DR, BDR. Okay, so I want to discuss this one as well, but let's discuss in next class. Okay, area type, backbone area we discussed already. Normal area, transit area, stub areas. We'll discuss this and we'll configure that in next class. Okay, so we just configure these all routers. Let me write this configuration. We'll continue from here. We have the neighborship. We'll check that how the route is going to be exchanged, how LSA is going to be exchanged, and rest everything we'll check in the next class. Any questions, guys? Any questions? Any feedback? Any suggestions? All good?
Sir, I have one doubt.
Yes, please ask.
Where we can use point-to-point, point-to-multi-point, some use case scenario.
Yeah,
Could
the
you please
point-to-point
tell?
network is basically when we have the ISP network. You're taking the links, ISP. Okay.
Okay, okay.
So they are just, /30 network. So why you need to DRBDR? You just have a two IP to need to communicate. So you just make the point-to-point network. Another case, let's suppose you have a ISP network, but you have the dual home scenario. Means you have the /29 subnet and you want to make the connectivity with the two routers. So you want to make a point-to-point. So you can use that point-to-point, sorry, point-to-multipoint.
Point-to-multi-point.
Yes.
Okay. Yeah. Okay. Thank you, sir.
All right. So thank you so much, guys. See you again next class.
Sir, I have another one doubt.
Yes, please.
For example, area 0 placed in someone location, and area 2 placed in someone location. For example, Delhi and Bangalore. So between that, someone ISP link is there, right?
Right.
So how can we establish the communication between the different areas? Here we can use area 0, we use OSPF, and area 2 we use OSPF. But between that we can't able direct. There is no direct link. We using one ISP between these two area, right? So
First, you have to
how?
understand this OSPF is not for the WAN connections. Okay. If you're using the two different distinct location, not recommended to use OSPF.
Okay.
Because ISP is never going to run OSPF for you. They use OSPF for the backbone for the MPLS, MPBGP, but not for your customer. OSPF, EIGRP, static RIP is a LAN protocol. So you should use the data center LAN infrastructure, not for the two different location. For two different location, you must have to exchange. Let's suppose your one OSPF route is running in the Mumbai, one is Delhi. So those routes are not going to come as OSPF route. They are going to advertise in the BGP, and from BGP you're going to get those routes. So you have to redistribute that BGP to OSPF. So it's not WAN routing protocol, it's a LAN routing protocol. IGP, Interior Gateway Protocol.
Okay, sir. Okay, sir.
Okay.
Okay, sir. I understood.
No worry, we'll discuss in next class. Don't worry. I'll take your questions again. Ask me again. Okay. I'll confirm how it is going to design. Or what is the follow-up question? By the way, you can ask what is the follow-up question? What do you not understand?
Like area 0 is like Delhi.
Area 0 Delhi. Let's suppose this is your Delhi branch. Okay.
Delhi. Okay,
Yeah.
Delhi branch. Area 22 is Mumbai branch.
Okay.
So inside our LAN, we are using OSPF.
This Mumbai, right?
Yes.
Mm-hmm.
So we can't able to link directly.
No,
So
we cannot able to link this ISP,
yeah,
right?
yes, ISP. So
Yeah.
here I have configured in OSPF internal LAN. I configured in OSPF, and the same like that Delhi I configured in OSPF LAN. So if I need to communicate with from area 0 to area 22 means how we can establish the communication here. Anyway, we can use one NAT translation, or we can create some
Oh,
IP
see,
sector.
so yeah, you have to build the IP sector and NAT translations. So once you advertise your route in the ISP, okay,
Yes.
this is route is no more OSPF route. First of all, plain area 22 is not recommended to use in the your LAN infrastructure. It should be must be connected to the backbone area. Okay, that is one
Okay.
recommendations. Okay, but
Okay.
still, let's suppose hypothetically you understand this area 22. So anyhow, you have to change the route from the OSPF to some other protocol. If you're using the IPsec, you have to send via the tunnels. Okay,
Yes.
GRE tunnel, and
Yes.
then route is going to there. See, this is going to receive as a non-OSPF route.
Yes.
Non-OSPF route.
Okay. Okay.
And this again going to advertise and receive as a non-OSPF route. There is no relation between these two. Just we can make the communication plane routing as a non-OSPF domain.
Okay.
Locally, it's going to
So
be OSPF domain. This is locally OSPF domain, but once they are going to redistribute in the routing protocols, let's suppose here we are running the BGP. So take an example. The moment you redistribute OSPF into the BGP, it's become the BGP route. So for this, here you receive the BGP route for this subnet, not OSPF route. Again, when it's going to be advertised here to here, it's come as a BGP route. Means when it's going to be advertised, it will advertise from the BGP to OSPF. So BGP route is going to become OSPF route. So technically, it's a BGP route for this one.
okay, I understood.
Okay. All right. No problem. Thank you, guys.